All right, so I'm going to solve this thing, only I'm going to use energy. Okay? How do you use energy? Well, to use energy, you've got to say that it falls a height. Okay? Now, ultimately, what we're going to solve for is the velocity at the bottom, right? The velocity will equal something. But you know what? To get from velocity to acceleration is not that hard. Okay? It's starting at rest. So remember, v squared is equal to u squared. It's a race. V squared is u squared plus 2as, right? Okay. In this case, it's falling a distance h, right? The initial velocity is 0. And so if I solve that for a, right, a is just simply v squared divided by 2h, okay, where h is our displacement, right? Okay, so all I have to do is get an expression for v squared, divide by 2h, and I should have the acceleration, okay? Now, when we did this before, we got that the acceleration in the dynamics video, we got that the acceleration was m2g divided by m2 plus 1/2 m1. Let's see if we can do the same thing using energy without using all the systems of equations and substitutions, which I think are mathematically maybe more difficult. I don't know. Okay, so let's set up our energy equation. Okay. Ultimately, we have m2 gh, right? And then in the end picture, this guy will be just about to touch the ground. It will have kinetic energy, and of course, this guy will be rotating at some speed, right? Hard to draw that. How do you draw that? Okay, so that's going to become 1/2 m2v squared, right? Plus 1/2 I omega squared for the cylinder, right? And that's it, right? So potential simply becomes all kinds of kinetic, right? Okay. So now let's substitute. We got m2 gh is 1/2 m2v squared, right? And then we go plus, and then we're going to do the standard substitution. So 1/2, and then let's substitute that I is 1/2 mr squared. And then let's say that v is equal to omega r. So omega is v over r, right? Okay, so 1/2 m1r squared times v over r squared, right? So that squared divided by that, right? Okay. And now we end up with, of course, the r's go the way of the bison, right? R squareds. And we end up with m2gh is 1/2 1/4. Now let's solve this for v squared, right? Equals v squared outside of 1/2 Okay. Now take a look. So v squared is m2 gh, right? Over 1/2 Now, that's what v squared is. Obviously, we can square root this. I could plug the numbers in, I promise you. And I could get this value. I know I could. But let me show you how to get the acceleration, right? Remember, acceleration is just from suvat, right? It's just v squared over 2h. So let's divide both sides by 2h, and we'll have the acceleration, right? Okay, so if I take this guy and I go, okay, divided by h, well, that's easy. The h goes the way of the bison, right? And then if I multiply the denominator by 2, I get acceleration is equal to m2g divided by, not 2 times 1/2 is m2. 2 times 1/4 is 1/2. There we go. Check it out. So here's the linear expression gotten from energy. Now, is this easier? I think that's easier. I think that's easier than setting up systems of equation and worrying about which way they accelerate or whatever. I'm just going to say that energy is the bomb for this. Okay, as these get more complex, you'll see that this is the case. Okay, So this is the simplest one, right? I can take these expressions, I can solve for v, I can solve for that, I can get exactly the same thing. Thanks for watching.